Thursday, March 24th, 2020, and our title for this lesson is Transformations and Algebraic Representations Continued. So we're going to go through this recording, guys, and you may press pause whenever you need to. Take this at your own pace, and then you can press play whenever you're ready to move forward. I do have a link here on the board. I will share that with you in the email that I send with this recording. All right, so today we are going to review transformations so that we can use an algebraic representation to explain transformations. And we'll know if we got it if we can successfully explain the effect of a scale factor applied to two-dimensional figures. Here is a quick review of the types of transformations that we have. We have a reflection here, which is a flip over an axis, either the x-axis or the y-axis. We have a rotation around a point. Rotations turn. Then translations are sliding or moving, and dilations are similar figures. We have enlargements and reductions when we are talking about dilations. All right, and so here is the page of notes over the algebraic rules for transformations. These are something you need to make sure and have written down in your notebook. Very important that you know these rules. Basically, guys, you're going to need to memorize them. That's the easiest way to make sure and keep up with all of the algebraic rules that you are required to know. Today we're going to be on pages 18 through 20 of your STAR review booklet. So make sure you have that with you. You have your math reference chart and you have your calculator. Again, guys, please just press pause while we go through this lesson, and so that you have time to work out each of the problems. Okay, so which of the following transformations do not preserve congruence? So think about that question. Think about what the word congruence means. Pick out the correct answer choice and then press play whenever you're ready. All right, guys. The dilations are the type of transformations that do not preserve congruence. So preserving congruence means that it is staying the same size. Dilations get bigger or smaller, so the size is changing. Translations, reflections, and rotations, those are types of transformations that are moving the figure, but the size does not change. Therefore, the congruence is preserved for those. Okay. Next up, I want you to write a rule for the following transformations. So press pause and write the algebraic representation for each of these types of transformations shown. All right, so here we have a, this one is a translation. It is moving, and you'll see that we go 6 places to the left. So that is x minus 6. And then, let me change my color there. Then we go 7 places down. So we have y minus 7. Okay, next up we have a reflection across the x-axis. So when you have a reflection over the x-axis, up here, I put a snip up here at the top from our notes. So when you reflect across the x-axis, the y-coordinate changes signs. So x comma negative y is our rule. And then finally, our last example here, we have a rotation. We have a 90-degree clockwise rotation. So our rule here is y becomes y comma negative x. So those coordinates are changing places and the x coordinate changes signs. All right. Here I want you to apply the following rule to the graph. to graph the transformation 180 degrees. So take a second and draw that rotation for me. Press play when you're ready to check your work. All right, so here, what I like to do when I'm drawing the rotation, because it's super hard to just look at the graph and draw that rotation, I know my rule for a 180-degree rotation is our X and Y coordinate, they stay in the same place, but they change their sign. So my original A is at 1, 1. So my A prime becomes -1, -1. And so then I can graph that point. My original B up here is at 1, 6. So my B prime becomes -1, -6. And then I can graph that point. And the same thing for C. My original C is over here at 4, 1. And so my C prime is -4, -1. And then once I have those 3 points drawn, then I can connect those dots and make my figure. So knowing that rule is very important. All right. Here we are asked to look at the relationship between the perimeter of figure ABCD and QRST. So you're looking at the relationship between the perimeter first, and then question number 2 says look at the relationship between the area. So take a second, press pause, and work that part out. All right. So the perimeter for figure ABCD is 4.3 centimeters, right? That is 1.25 plus 1.25 plus 0.9 plus 0.9, and that is equal to 4.3 centimeters. The perimeter for QRST is 8.6 centimeters. So that's 2.5 plus 2.5 plus 1.8 plus 1.8 for the perimeter. So you'll see that the perimeter is 2 times the original. Okay, then for the area is a little bit different, so pay close attention here. The area here for ABCD, 0.9 times 1.25 base times height, the area is 1.125 square centimeters. The area for QRST, 1.8 times 2.5 gives us 4.5 centimeters. So the area is 4 times the original. So you have to be very careful when you are looking at those. All of the dimensions are double. So why is the area not doubled? I want you to think about that question. If the dimensions are doubled, the perimeter is doubled, why is the area not doubled? And so this comes into our dimensional geometry here. If you'll think about it, when we're talking about area, we're talking about square units. So 2 squared is 4, so that's why it is 4 times. When we're multiplying, not just adding together the sides there, that's why the area is not just doubled. We're talking about 2 dimensions there being doubled. So let's take a look at the interim questions over this topic. So this was question number 9. It says triangle ABC was transformed to create triangle ABC prime. Which rule best describes this transformation? So press pause and work this question out, pick out the correct rule, and then press play when you're ready. All right, guys, this is a translation. This figure is moved down 7 places. If you look at B and just look at each coordinate there, everything is moved down 7 places. So x stays the same, but to go down 7 places, we have that y minus 7. All right, then we have question number 38 from the interim. Quadrilateral PQRS was translated 5 units to the right and 3 units up to create quadrilateral PQRS prime. Which rule describes this transformation? Pick out the correct rule and press play whenever you're ready. All right, the correct rule here, to move 5 units to the right, that is x plus 5. 3 units up would be y plus 3. So B is the correct answer here. All right, I have a couple of star review questions. These came from previous star tests. So a figure is graphed on the coordinate grid as shown. The figure is rotated 180 degrees clockwise with the origin as the center of rotation to create a new figure. Which rule describes this transformation? So pick out the correct rule for me. All right, so when we're looking at a 180 degree rotation, our rule is negative x, negative y. Our coordinates stay in the same place. They do not trade places, but they change signs. All right, last one. It says triangle RST is translated 6 units to the left and 4 units up to create triangle RST prime. Which rule best describes this transformation? And the answer here is D. If we are going 6 units to the left, we are doing x minus 6, and then 4 units up is y plus 4. So D is correct here. Very good. All right, guys, awesome job today using our math vocabulary to describe transformations and explain the effects of transformations. Here is a list of your assignments for this week. Guys, if you have any questions or need help with anything at all, please send me an email and we will work something out. I am happy to help. I'm here. Hang in there during this. Reach out